Hello dear students, I am recording this presentation to brief about some of the concepts related to microbial control. In that, the part 1 is discussing about conditions influencing antimicrobial action. So let us go further in understanding which are the factors which are considered to be important while we are trying to control microorganisms with use of certain physical or chemical agents. So this is a list of these factors. The nature of the site to be treated, population size, population composition, physiological state of a cell, intensity of physical agent or concentration of chemical agent which are going to be used as an antimicrobial agent, duration of exposure and environmental factors. These are the essential factors need to be considered. Let us try to understand them in some detail. So why we need to consider this factor? It's because not a single chemical can be applicable to each and every object and in different conditions. We need to select out of the range available, out of the wide range of the things available to control microorganisms with respect to our application, with respect to our purpose. So the first is the nature of the site to be treated. When we want to apply this any agent to the plastic items, and if we talk about the something to be applicable to the metal items, definitely our requirement will vary. We cannot apply high temperature for the microbial controlling on the plastic material. The same can be applicable to the metal items. Similarly, we need to take into consideration animate or inanimate objects for which we are trying to apply some agent. Now, second important thing, what is the purpose of applying some agent to a particular object? If we want to use that object further for which is going to come in contact with the living beings through the skin or to the mucous membrane, definitely it should be done or it should be disinfected or sterilized using a substance which is not going to be retained by that object. So the nature of or the site of which is going to be treated by the antimicrobial agent has a great consideration to be taken into consideration while selecting an agent. Next is population size. Now, as you know from the concept of the death rate, that it says that with the equal time duration, equal fraction of the organisms are destroyed or inhibited. Looking to the same concept, we need to take into consideration that if we have some area to be disinfected or to be sterilized, if that area or that object is carrying a huge population of an organism, it will be requiring larger time period of exposure for the reduction, complete destruction to be achieved, right? So the larger the population, longer will be the time required for the microbial control. Next is population composition. Now various perspective can be taken into consideration when we talk about the population composition. For example, if we take into first concept account that there are some of the organisms which are highly susceptible or sensitive to the antimicrobial agents. Compared to that, there are other organisms which are highly resistant, like as can be seen over here. I have taken an example of Mycobacterium tuberculosis. As it possesses the vaccine material in its envelope, it provides the organism and a resistance mechanism not to be destroyed easily. Second, if we take into consideration whether the organisms are existing in vegetative cellular form or the spore form. If they are existing in cellular form, they can be liable to be easily destroyed compared to the spore forms, because spores are dormant resistant structures, as we all knows it. Similarly, the fungal spores or the yeast spores, and in case of protozoa, the cyst forms are little bit more resistant or dormant structures, and they can be they will require some larger exposure period for the destruction as compared to their vegetative cellular forms. Next, physiological state of the organism. Now, when we think of in which state of the growth, if organisms are existing in the their tender age group, or if they are younger cells, they are more easily destroyed by exposure to the any physical or chemical agent. But aged cells or the old cells have acquired some mechanisms during their lifespan, and they cannot be easily destroyed by the agent. So, younger cells are easily destroyed as compared to the aged or old cells. Next is intensity of the physical agent or concentration of chemical agent. As you can understand that when we try to destroy the organism using a physical agent like heat, the higher the temperature, it will give a good result of microbial control. So that is something about intensity of physical agent. Temperature increment in case of heat and increasing the radiation dose can be said to be increment in intensity, right? So intensity, increasing the intensity of the physical agent, and comparatively, if we talk about the chemical agent, we can increase the concentration of a chemical to have the similar sort of effect. But for certain chemicals like alcohol, this will not be the same fact. We are going to discuss same in the later presentations to come. Next is duration of exposure. We have seen that from the death curve, the number of organisms will determine the time required for complete destruction to be achieved. That is something about duration of exposure. If you expose certain object to the antimicrobial agent for a longer period of time, you will be able to get the better results with respect to antimicrobial reduction, microbial load reduction. Next is environment. A huge impact of the external environment can be there on microbial control activities. If we are applying some chemicals in an area which is having a ample of organic substances or the dirt like inert material, it will causes the reduction in efficiency of the chemical to destroy the organisms. Similarly, temperature is considered to be one of the important such factor. Temperature of the environment has direct impact on activity of any antimicrobial agent if we take into consideration the chemical agents. Second is pH. pH has also shown its great impact on microbial reduction. As an example, if we try to destroy the organisms when they are in acidic environment, it will be more easy compared to compared to condition where they are in alkaline condition. So, pasteurization of milk will require, which is alkaline, little alkaline in nature. Pasteurization of milk will require the higher temperature as compared to the pasteurization of the fruit juices, which are acidic in nature. Next is consistency of material. If we take into consideration something which is liquid or semi-solid in nature, the consistency of that material has a great impact on penetration of the heat or some chemical inside the object, right? So it will require, if the material is highly viscous, it require more time for the penetration to take place for the agent, and thus the duration of the exposure will be required to be more. So consistency of the material is also the very high influence on the antimicrobial activity of any agent. These are some of the figures I have taken from the reference books. Like for example, in this figure they have tried to show the effect of phenol which is taken at fixed concentration, and they have tried to check the changing temperature, that is environmental condition. And as can be seen from this diagram, that logarithm of the survivors when taken in comparison with the time, by increasing the temperature from 30 degrees centigrade to the 42 degrees centigrade, we are able to achieve the reduction in the survivors, reduction in the number of survivors very rapidly, right. It is at 30 degrees centigrade we are not able to achieve the reduction up to 0, that is no survivor even after the end of 2000 minute. But if the temperature has been elevated to 42 degrees centigrade within time duration of less than 200 minutes, the reduction has been achieved up to almost 0, right. So concentration of phenol is kept constant over here, but on the changing in temperature has a great impact on antimicrobial effect of the phenol. This is table taken again from the one of the reference book, which in which they have tried to show that the different forms of the organism will show the changing resistance or variable resistance against the same chemical or the physical agent. As an example, if phenol is taken as an antimicrobial agent to kill the organisms, for example, if E. coli is taken as unity, means if it is we are able to kill successfully the Escherichia coli with the help of phenol. In comparison to Escherichia coli, the bacterial spores require so much high concentration of phenol for its reduction, right. Compared to that, the very less resistance is expressed by the mold spores in comparison to bacterial spores, and viruses as well as bacteriophage are also able to show some resistance, some good resistance even in comparison to the mold spores, but the bacterial spores are showing very high resistance against the phenol, right. So from this table we can understand that bacterial spores are most resistant form of the structures encountered in nature and difficult to destroy. These are the references I have used for this presentation. Thank you.